Welcome to our third lesson video. This one talks about relations and functions. By the end of this lesson, you are expected to be able to define a relation and a function, determine if a relation is a function, represent relations and or functions as a table, set of ordered pairs, mapping, or an equation, and lastly, be able to understand function notation and how to find the value or the output of a function given an input and vice versa. Make sure you're paying attention in this lesson videos. There's going to be several questions that you will need to write down the answers because you will need to submit those answers later on. Before we get started with discussing functions, let's do a quick review of what ordered pairs are. Ordered pairs is just your pair of x and y coordinates, and you use them to locate points in the coordinate plane. If you remember that an ordered pair has an x coordinate and a y coordinate. If we were looking at this one right here, let's say I gave you a coordinate 3, 2. That means I go 3 units on my x-axis and then 2 units up. So my point or my ordered pair 3, 2 would be located right there. We can mark that. 3, 2 would be right there. Now it is important for you to remember how ordered pairs work, because you will see that once we start talking about functions, relations, you can tie in these functions and relations into graphs, tables, and mapping. Just to reiterate, an ordered pair has an x-coordinate and a y-coordinate. Right here, your x-coordinate is -3, and your y-coordinate is -2. So you go -3 units in your x-axis, and then you go 2 units up on your y in order to plot that ordered pair -3, 2. So now let's do a quick practice. If I'm looking at this right here, this graph right here, I'm looking for the ordered pair or the coordinates of point A. Take a little time to look at that and then let me know what you guys think. This would be the part where you can pause and think about it, a problem, or if it was an equation, you can solve that equation and then you push play again to see the answer. Now for this point, point A, the coordinate of this would be 1, 3. It is located at, it has an x-coordinate of 1 and a y-coordinate of 3. Here's another quick practice for you guys. You're looking for the coordinate of point B, or what ordered pair represents point B. For this one, the coordinate or the ordered pair that represents point B would be x-coordinate of 3 and y-coordinate of -2. You can see 1, 2, 3. That's your 3 right there. And then -2 because you are going down the x-axis. Here we have another example. What would be the ordered pair for point C? The answer for the coordinate or ordered pair for point C would be 0, -4. You can see that it's 0 because it did not move from the x-axis, and then it went down 4 units, 1, 2, 3, 4, down the y-axis, and that's where your -4 comes into play. One more time, one last practice. What is the ordered pair for point D? Right there. The ordered pair for point D would be -6, -1. Now on the next slide, I'm going to ask you guys to write down your answers because you will turn that in as part of your homework. So pay attention on the next slide, if you haven't been paying attention. So just as a final practice for ordered pairs and plotting them in the graph, in the xy coordinate, I want you guys to name the ordered pairs for the following points, A, B, C, and D. There's point A, B, C, and D. I want you guys to write down your answers because I'll give you guys a link where you are going to submit your answers for these questions. Now that we've reviewed plotting ordered pairs, let's take a quick look at quadrants. Quadrants is just the four regions that divide your x and y coordinate plane. Here's the first quadrant where the x coordinate is a positive and the y coordinate is a positive. Here's your second quadrant where the x coordinate is negative and the y coordinate is positive. Third quadrant where both your x and y are negative numbers. And your fourth quadrant where your x coordinate is a positive number and your y coordinate is a negative number. The next slides will give you some practice on knowing what quadrant a certain ordered pair or point falls in. Our first example, name the quadrant in which each point is located. We're looking at the point negative 5, 4. You can see that the x coordinate is negative and the y coordinate is positive. If I'm looking at my coordinates, that would fall under the second coordinate, or the second quadrant. We're looking right here. Quadrant 2 has a negative x coordinate and a positive y coordinate. Let's look at another example. For this problem, we are looking at what quadrant the point negative 2, negative 7 falls under. We're looking at a negative x coordinate and a negative y coordinate. That means this point right here would fall under quadrant 3, right there, quadrant 3. Now for this last one, I want you to do this by yourself and record your answer. You will receive the link in which you can turn in your answer for this question at the end of the presentation. So why did we review plotting points in ordered pairs and the quadrants? Well, because relations, a simple definition of relations is ordered pairs. Remember, we're talking about input and output when we were looking at functions. Well, relations just tell you where a certain input outputs to. So right here, if you're looking at ordered pairs, if you have an x coordinate of 1, you got a y coordinate of 2. If you have an x coordinate of 4, you have a y coordinate of 5. X coordinate of 8, y coordinate of 9. So really, you've been studying relations before. It just was never called relations. They were called coordinate points or ordered pairs. Note that your x coordinate is your input and your y coordinate is your output. Keep these two terms right here because you will see domain and range again in the next lesson. So now let's take a look at the definition of functions. A function is a relation in which each element of the domain, so each of your input, is paired with exactly one element of the range. That just means that your input, each one of your inputs, only goes to one output. You can't have an input that goes into two different outputs. So that is your definition of a function. This right here is the key word. It goes to one and only one output. Each input goes to one and only one output. Now, if you have a relation where the input goes to two or more outputs, then that relation is not a function. Here's a quick review of function notation. Now you will see most of the time, let's add a little bit to this. Let's say this is 3x plus 2. You can see that whatever the 3x plus 2 gives you, that would be your output. The f is just a name of your function. That could be any letter or shape that you want. For our purposes, it'd mostly be letters. It'll be f of x, g of x, w of x, as long as you can kind of remember what the name of your function is. And then whatever's inside the parentheses, that's your input. We will take a look at how we evaluate functions using function notation in the later slides. Just remember that the f is the name of your function. It's not f times x. It's f, if you're reading this, you're reading it as f of x. So let me write that down. It's read as f of x. That's how you read a function. So we were looking at earlier at relations and trying to figure out if a relation is a function. Well, to figure out if a relation is a function, we need to remember that each input needs to go to only one output. One way to do this is by mapping your input and output. So if I'm mapping this, I'm going to write down all my inputs. I have 2, 3, 5, and 4. Then I'm going to map out all my outputs. Here's my input. Here's my outputs. It's 3, 0, 2, and then I'm not going to write another 3 because the 3 is already there. So now let's map it out. Input 2 goes to 3. Input 3 goes to 0. Input 5 goes to 2. And then input 4 goes to 3. Notice that none of the inputs have more than one output. That being said, this relation right here is actually a function because all the inputs go to just one particular output. There you go. Each domain, each domain only goes to one and only one output. So this relation right here is a function. Now let's take a look at another one. So now let's take a look at this relation. We have a relation with several ordered pairs or coordinate points. We have 4, 1, 5, 2, 5, 3, 6, 6, and 9 or 1, 9. By using mapping, we need to see if this relation is a function, if it has a one-to-one relationship. So if we look at this, if we actually map this, you will see that my inputs right here, 4 goes to 1, 5 goes to 2, but then here I have another 5 that goes to 3. So that means that my input, 5, goes to two different outputs. One goes to 2 and the other one goes to 3. So that means that this relation is not a function because 5 is paired or outputs to two different numbers. Remember that for a relation to be a function, each input goes to exactly one output. Alright, try this problem out. I want you to determine if this set of ordered pairs or relation is a function. Please record your answer so that you can have that later on when you turn in all your answers to all the questions from this presentation. If you remember from the earlier slides, we were looking at relations as ordered pairs or coordinate points. So that means that we can take a look at tables and actually plot a relation. Well, in the previous slide before this one, you were able to look at the ordered pairs, essentially the data or the table of it, and determine if your relation is a function by looking at your input and output. Well, there's another way for you to test if a relation is a function. That test is called the vertical line test. Now, the vertical line test tells you that if you have any vertical line that passes through more than one point, that's the keyword right there, more than one point of the graph, then the relation is not a function. So here's the examples right here. If you look at this first one right here, here's the function. It's a graph right there. It's a it's a slanted line. I draw several vertical lines. If you look at all the vertical lines, you can see that each vertical line just hits that slanted line at one point. It doesn't hit it more than once each vertical line. Because the vertical lines only passes through that graph of my relation at one point, then this right here is actually a function. Here's another example right here. Here's our graph. It's like a U-shaped graph that's actually called quadratic, and we'll get to that more later on. So here's my quadratic graph right here. If I draw several vertical lines, you can see that it only intersects my graph once for my vertical line. Now, if any of my vertical lines hit the graph more than once, then it's not a function. Here's an example of that one. Here's my graph of my relation. It's like a little oblong right there. The key term for it in math would be ellipse. So I have an ellipse right here. Notice that if I'm looking at this correctly, if I draw a vertical line right here, notice that my vertical line hits it up there and intersects with it down here. My other vertical lines hit it up there and then down here. Because there are two or more intersections, and I'm running out of space right here, intersections with my vertical lines, that means that this relation right here, the graph of my ellipse, is not a function. So if there is two or more intersections, or if any of my vertical line hits your graph more than once, then it is not a function. Let's practice this on the next slides. Alright, so we're trying out the vertical line test with different graphs. You can see right here that my graph is a horizontal line. It's the red line right there. I draw several vertical lines. It only hits the vertical lines once. Sorry about that. Once, so that means that this relation right here, this horizontal line, is actually a function. Now over here, you can't quite see it clearly, but there's actually a red vertical line right here. So if I draw several vertical lines, you will notice that that vertical line right there, the black one, actually intersects all of the red one. Because the vertical line intersects it at more than one point, then this relation right here is not a function. It's not a function because it intersects it at more than one point. This one right here, the next one, you have this sideways quadratic. If you draw vertical lines here, it doesn't hit your graph. But then if you go further down here, you can see that there are more than one intersection points with the vertical line. So that means that this graph or this relation is also not a function. Lastly, with this one right here, you have this weird looking kind of S. That's actually a cubic graph. You'll see that more in Algebra 2. But anyway, if you look at this, you draw your vertical lines. You can see that each vertical line just hits your graph at one point, no more than 1 point. So that means that this graph is actually a function. Guys, the vertical line test is a quick way for you to figure out if you are looking at a function or not a function or just a relation. It's easy because if you can plot it using your calculator or using a graphing paper, you can easily see if your equation or your table or your set of ordered pairs, if they pass or fail the vertical line test. If it only intersects it no more than one time, then it is a function. If any vertical line intersects your graph more than once, then it is not a function. And sorry for that bell. Now let's move on to some more stuff. Now take a look at this graph right here, this V, that's your absolute value graph. Take a look at this graph right here, and using the vertical line test, let me know if this graph is a function or if it's just a relation. Write down your answers because you will put those answers later on at a link provided at the end of this presentation. Alright guys, hang in there. We're towards the end of this presentation. Now we are going to take a look at evaluating function notation. So right here we are given f of x is equal to 3x minus 2. Now it's asking us to find or evaluate, that would be the other term that you may see, evaluate the function when x is equal to 3. So right here, we know that x is equal to 3. That's that part right there. Because whatever's inside the parentheses, the x inside the parentheses, was changed to a number, that means your x would equal to 3. So now to work this out, what you're going to do is you're just going to write down f of 3 is equal to, you're going to replace all the x's with a 3. So now rather than having 3x, you're going to have a 3 times 3. And then you continue 3 times 3 minus 2. That'll give you a 9 minus 2. And then you keep working that, so you'll know that f of 3 is equal to 7. So that means your ordered pair, remember it's the x coordinate and then the y coordinate. So when x is 3, y would be 7. So now you have that right there, and you can plot that if you needed to plot it. Now if we're looking at another example right here, now we're evaluating this one when x is equal to negative 2. So now we're going to replace the x with a negative 2. So we're going to have f of negative 2 is equal to 3 times negative 2 minus 2. If you continue working this out, 3 times negative 2 will give you a negative 6 minus 2. So now we know that f of negative 2 is equal to negative 8. That means that when x is equal to 2, or negative 2, sorry, your y coordinate would be equal to negative 8. So right here, guys, this is how you evaluate a given function. Evaluate just means that you're finding, and sorry for that bell again, that just means that you are finding what the value of the function is given a certain x value. Take a look at another example. This time you are given a function h of z, which is equal to z squared minus 4z plus 9, and then it's asking us to evaluate it when z is equal to negative 3. It says find h of negative 3. So that means that z, oops, you can't see that. Let me try that again. That means z is equal to negative 3. So if we're working this out, we're going to write down h of negative 3. So that means anywhere where there's a z, we just changed it. Remember, that's the name of the function. That's the input. So now our input is negative 3. So we're going to write it out. We're going to have a negative 3 squared minus 4 times negative 3. We're replacing all the z's with negative 3 plus 9. We continue working this out. You're going to end up with negative 3 times a negative 3 is a 9. 4 times negative 4 times negative 3 is a positive 12. And then plus a 9. If we add that all up, you're going to end up with h of negative 3 is equal to 30. So that means when z is equal to negative 3, the output, this is z right there, and then the output h of z is equal to 30. So this is how you evaluate a given function. Try this one out. You're given g of x is equal to x squared minus 2. I want you to evaluate g of x when x is equal to 4, or I want you to find g of 4. Write down your answers because you will submit those answers in a Google form. In the past two slides, you were trying to find f of x when you were given a certain input or x value. Well, now you are going to find what your input is when you're given a certain output. Right here we have f of x is equal to 5x plus 3. It's telling you to find what your input is when your output is 7. So that just means that I'm going to change my output to 7. So I'm going to have 7 is equal to 5x plus 3. I am now going to solve for x. So I'm going to subtract 3 from both sides. And you're going to end up with 4 is equal to 5x. Now divide both sides by 5. Now I find out that x is equal to 4 over 5. So this right here, this means that when my output is 7 for my f of x, the input should be 4 over 5. So this right here, what I'm showing you right here, is just a reverse of what we did in the previous two slides. Rather than looking for f of x when you're given an x, this one you're given an f of x and you're solving for your input. So rather than looking for the output when given an input, you're looking for the input when you're given an output. Now try the next, we'll go to the next slide and you can try that example right there. So try this one out. You are given the function k of x is equal to 5x plus 13. I want you to find the input x when your output k of x is equal to negative 12. Write down your answer and you're actually going to submit that answer on the last slide. Now for the last problem, this one right here, you are given the input, or you're given the function g of x, and g of x is equal to x squared plus 4x plus 2. I want you to find the output for g of 3 when x is equal to 3, g of x when x is equal to negative 2, and then once you find those, I want you to work out this expression right here. So you will have three answers here. You'll have a g of 3, g of negative 2, and then the answer to 4 times g of 3 plus g of negative 2. Write down your answers and your solutions to that, and you will be submitting that to the website on the next slide. We've reached the end of lesson video 3. All the questions that you answered throughout the video, you will need to submit your answers using this website right here. And that's how you will get credit for watching this lesson video. If you have any other questions, please stop by during tutorials so I can help you out with understanding relations and functions.